This video is for Chapter 12, Section 5. It'll be the first video for this level, although we are studying Chapter 12, Section 5. It's all about the equation of a circle. We've been looking at circles throughout the year, and we have to remember a circle is defined as a set of all the points equal distant from a point called the center. So it's like picking a point in space or on the ground and driving a stake into it, and then taking a distance or a rope that is 1 foot long, attach it to the stake, and then you can move the end of that rope around in a circle. And that line or that circle on the ground would represent every single spot that is 1 foot away from that center point. Now, because circles are all based on distance, it sort of makes sense if it makes it based on distance, then the Pythagorean theorem has to show up, because the Pythagorean theorem is where the distance formula came from. So we're going to take a look at this circle here, where the circle has a center and it has a radius that touches every point on the circle. Now if we put the center on the origin, then every point on the circle is a certain distance to the left and a certain distance up from the center. Now left, up, horizontal, vertical, these things are perpendicular to each other and form a right triangle. So we can put together by looking at this picture that x squared plus y squared equals r squared. This is the basic Pythagorean theorem applied to the right triangle formed inside of a circle. Okay? Now, this equation is only true if the center of the circle is on the origin. It would not work if the center of the circle was off the origin at, for example, a spot that we might call H and K. This will be the point for the center of the circle. And here's what how it'll change the formula. Look at this picture. Now the center of the circle is here at HK. The right triangle has not changed. The radius is still the radius. However, the point x comma y, which represents any point on the circle, this distance x is from the origin. And so we don't want the part from here to here, which represents h. So the distance of this part of the triangle, using the distance formula, would be x minus h. It's the x2 minus x1 part of the distance formula. X minus h. And the vertical part is now y, y2, minus k, which is y1. So now we have three sides to the triangle, x minus h, y minus k, and r. If we put these as the sides of the triangle into the Pythagorean theorem, we get this formula. X minus h squared plus y minus k squared equals r squared. And the things we have to define here are h and k represent the center of the circle, r represents the radius, and x and y are your variables. They represent any and all points on the circle. If you had a point on the circle, you could use those as x and y. Otherwise, x and y should be in the equation as variables. Let's take a look at some examples. So, first we have, write the standard equation of a circle with the center 3, 5 and radius of 6. So this is just taking the basic equation and plugging in the things that we know. 3 is h, 5 is k, 6 is the radius. So we have x minus 3 squared plus y minus 5 squared equals 36. Notice I didn't leave 6 squared. I actually squared the number 6 and wrote 36 for r squared. And inside the parentheses is the opposite of h. H was 3, so it's the opposite, x minus 3. K was 5, y minus 5. We can look at it here where we have negative numbers for the center and a radius that has a radical. Well, it would still be x minus negative 2. I've just changed the subtracting a negative into a positive. X plus 2 squared plus y plus 1 squared. And then the radius is radical 2. Radical 2 squared is 2 itself. And there's your r squared. Third example. What if we needed to write the standard equation of a circle where we have the center, so we're given h and k, but it goes through the point negative 1, 1. Take a moment and think about, what does the point negative 1, 1 represent? Well, it represents the x and y. It is a point on the circle. So what we're missing is r. Now, the technique I'm about to show here is similar to when finding linear equations y equals mx plus b. When you're given a point and a slope and you go find the b value, then you later rewrite the equation y equals mx plus b. We're going to use the point and the center to go find the radius. So the equation would be x minus 2 squared plus y minus 3 squared equals r squared. So first we substitute h and k. Now we don't have r, but we have x and y. So next we substitute x and y into the equation and solve for the radius. Negative 1 is x, minus 2 is negative 3. 1 minus 3 is negative 2. And we square these. Negative 3 squared is 9 plus negative 2 squared, which is 4. So r squared is equal to 13. If we square root that, we get the radius, radical 13. However, we want to write an equation, so now we go back to x minus 2 squared plus y minus 3 squared, and we replace r with radical 13. Radical 13 squared would just become 13. Okay, our final example is going to be, how do we find the radius and center from an equation, and then how could we graph these? We're going to have a real simple process for graphing. So finding the center and the radius is probably the easiest part. If it says x minus 2, then the center is at positive 2. If it says x plus 3, then the center is at negative 3. In this case, y plus 3. So the center is at 2 comma negative 3. And if r squared is 100, all we have to do is square root it. We get 10. Now, we know where the center is. We know what the radius is. We're going to use those two things to graph it. So first, plot the center. So make an xy coordinate chart or get some graph paper. Go put a dot at 2, negative 3. Then find 4 points. One straight up, one straight down, one to the left, and one to the right. Each that has 10 units away. Okay. So it would look something like this. I would have 2 comma negative 3. There's my center. Here's my line drawn to represent my radius. And 2, negative 3. If I go up 10 spaces, from negative 3 goes up to 7. From positive 2, you go out 10 spaces, you're at 12. Left 10 spaces, you're at negative 8. Down 10 spaces, you're at negative 13. Connect those 4 points. Put a radius on where you label. Okay, make sure you draw the circle and label the center and the radius. These two things are more important than these 4 things. These right here, center, radius. That's it for Chapter 12, Section 5. You can begin working on assignment number 1.